Okay, let's get this formally started. This is the April 21 meeting of the Kubernetes IoT Edge Working Group. Uh, this group, like all other groups in the Kubernetes project, abides by the Kubernetes Code of Conduct. The summary of that is just be nice to each other. That also means that all meetings are public and recorded and will be posted on YouTube after some latency of downloading and checking it out. Um, so with that said, um, the recording, I think, is already started. Yes. So let's get going on the agenda today. Um, we have, I'm not, correct me if I get your name wrong, Faye, or I'll let you say your name,
Hey,
who's a lead on the OpenYurt project, and he's going to give us an introduction. Faye, just so you know that this group has been following some of the other Kubernetes for Edge solutions for some time. Um, Principally Edge, I think, got started here a few years ago. So I think people are more familiar with that than some of the other solutions. So maybe it'd be useful not only to describe OpenYurt, but maybe compare it to some of the other things out there as well.
yeah, I understand. So I don't put the direct comparison in the presentation slides, but this won't go. I mean, this I may take 20 to 25 minutes. So, but in the rest of in the Q&A sessions, we can discuss the difference between this OpenYurt and Kubernetes. But I'm guessing during the presentation, you guys probably will figure out what's the difference. Anyway, so yeah, I understand. So, anything else? Should I start or?
Yeah, I think Steve, you're muted. But yeah, I think we can get going.
Yeah, go ahead and start.
Okay. Let me see. Yeah. Can you guys see the slides?
Yeah.
Okay. Yeah, good morning, everyone. Today I'm going to give you a brief description about the OpenYurt project, which I was working on in Alibaba. My name is Fei. I come from Alibaba Group. Okay, let's get started. So this is the agenda of my today's talk. I give you a brief background about this project and kind of edge computing in general, and I will discuss some challenges that we face when we try to do the edge computing support in the Kubernetes. I will give you some high-level design about OpenYurt. How does it resolve those challenges? And I give a kind of short description about the use case where this project and where this solution was used for. And I think in the rest of time we can have some Q&A, and I can answer any questions you guys have. Okay, so edge computing in general. So I guess you guys are quite familiar with this diagram. So basically, we are trying to resolve use cases like the workload was running the edge, and the workload typically runs the distributed algorithms. The characteristics of the workload is that the local data was generating the edge side was the input, and usually the edge application will do some analyze or data mining or machine learning training work in the edge node, and the results will be sent back to the center, which is in the cloud. And the typically workload was managed in the cloud by the central place, which is the cloud. The driving force of having this architecture is due to a few reasons, like low latency, low bandwidth between the edge and the cloud, and some kind of autonomy, because in the edge, due to various network connection problems or maintenance problems, they may sometimes get disconnected from we need to maintain kind of autonomy without the central control plane, and then the edge side still can handle some kind of errors or like node reboots, things like that. And another thing is very important, which is privacy and the security. So many people don't want to send all the data generated in the edge side to the center because they are, you know, aware, they are conscious about, or they are concerned about, you know, leaking the information from those many data. That's the reason. So I think edge computing is getting more and more promising in solving kind of real use cases. So in general, so the cloud edge computing is, you know, a platform, which is a platform that unites the cloud edge nodes and the IoT devices. In this, you know, in this architecture, the cloud typically is a centralized control plane, and edge is composed of the compute nodes that are closer to devices or data, but devices are is entry point to the remote environments. Is essentially the data generators, which are sent as the input for the application running in the edge nodes. Yeah, this is kind of typically the architecture we are trying to tackle in the OpenYurt. Yes, just give a brief description about the Kubernetes. I think everybody is quite familiar with it. In general, it is a is a container orchestration platform, which is de facto the people are thinking this as a cloud operating system. It has been used in many use cases, and all major cloud vendors has support for the Kubernetes services. I think the nice thing of Kubernetes it has a unified user experience that abstracts away all the underlying architecture or ICE layer details, and people can use the same interfaces, APIs, YAMLs, and apply the workload in almost any environments. And another good thing of Kubernetes, it has a very strong ecosystem because it has a very excellent, very good extensibility by leveraging the CRD capabilities. Yeah, I'm just give a very quick. So that's the reason. So I think many solutions, including the edge computing solutions, are come up with the supporting or running based on the Kubernetes, like KubeEdge that Stephen has been mentioned, and the OpenYurt is another case. I think Kubernetes in general, from architecture wise, is kind of fits the edge use cases and architecture because it is essentially a distributed system. So if you look at this mapping, so the Kubernetes, you can just put the Kubernetes masters in the sense that the API server, a scheduler, controller manager, you put those part as a control plane part and put it in the cloud. Then in the edge side, you just put node daemon like Kubernetes running the nodes in the edge side, and that's it. And that's a typical Kubernetes architect. And the device in the device layer, they have benchmark. You have all sorts of edge side devices like camera, sensor, cars, hospital, factory. Then those devices connect to the nodes in the edge. And if you show some dash line here, the dash line typically means the nodes, the one cluster, the Kubernetes, the nodes in one cluster may belong to different regions. The regions is kind of, you can see those regions like factory, like a building. So they have some kind of local affinity kind of thing find together. So this is pretty common in this Kubernetes edge architect. And we hope we have some solutions and can optimize this scenario such that the nodes itself has a kind of local affinity kind of features. Yeah, so next I'm going to describe some challenges if you want to use Kubernetes to manage the cache use case, the edge use cases. What are the challenges we face? At least 3 challenges which are addressed in OpenYurt. I will also list some other challenges that have not been addressed and which are also our future work. The first problem is unreliable network. So it is pretty much is true. So when we talk to the edge customers that use edge solution, they often ask, saying that the networking connection between the centralized control plane and the edge may not be always on. So that's one constraint. But the biggest problem is the Kubernetes. This is not a correct assumption in Kubernetes. Kubernetes assumes that Kubernetes always has a connection with the API server. Otherwise, if we don't anything, if we don't do anything, if you just cut off the nodes and the API server, if your nodes restarts, none of the pods will be recreated by the Kubernetes. So that's a limitation of the Kubernetes architecture. Another problem of having an unreliable network is that the Kubernetes API server relies on the harvest to detection the node offline. And so you guys know, so there is a node controller which will evict pods if the node has been detected as offline, which is a good feature to support high availability for the application. But in the edge use cases, this is a problem. So even though your application is still running a node, but if you cut off the connection between the node and the API server will start to evict the pods from the server side. Yeah, that's one problem. Another problem is the unidirectional network. So usually the edge nodes resides in the internet, so which you can access the public IPs through the SNet, but the outward component typically cannot access the individual nodes within the internet. So so this and the problem of this unidirectional network is that some Kubernetes API, which is very important for Kubernetes users for debugging or auditing, such as the log and the exec APIs, cannot be supported in this networking scenario. So which is another problem that we are trying to resolve. The last one is the pool wire. The pool is the one that I was mentioning in the previous slide, that some nodes that can form a pool which reside in the same factory, same building kind of thing, or same hospital in the sense that if you have a centralized controller, the Kubernetes cluster to manage many hospitals. So we are trying to, so people always find challenging if you want to deploy the same applications across different pool or different regions. Currently, there's no formal tools or workload to support that. And this is another thing that we are trying to resolve. So basically providing a pool-aware application management. So these three things we are trying to tackle, and we're trying to resolve through the OpenYurt.
So I guess if that last one is just getting at the point that in Kubernetes, in general, any pod expects to be able to reach any other pod in the same cluster, right? And you're deploying at edge or multiple edge locations potentially breaks that, and you're trying to address that. That's what you're saying, right?
That's one aspect. Another aspect is that we see cases that the people trying to deploy, let's say one cluster manages three hospitals. Three hospitals are in three regions. They have the same set of software, but with different versions. So they want to have an easy way to manage this type of application, basically spread to different regions with different versions or different parameters kind of thing. So usually you will have, let's say you will create 3 deployments, 1 deployment for 1 hospital, but this solution may not scale well. If you have 10 hospitals, you need to create 10 deployments. So we introduce, I will talk about later, we introduce a workload controller, says United deployments. Basically, you can deploy the same set of applications to different regions with slight differences. So you use one controller to manage the lifecycle of multiple copies of applications.
Okay, thank you.
Yeah, so that's another part of the pool-aware application management I was talking about. I will give more details later. Another two challenges that I think which is also important. The first one is the resource requirement. So in the, I don't think this is a big blocker from now, because nowadays I think people usually have decent resource, usually not all, usually have decent resource in the edge side to support running these components that Kubernetes needs, because OpenYurt was built on top of the Kubernetes. So you need to install all the default Kubernetes components anyway in the edge side, including Kubernetes proxy, CRI, kind of thing. No doubt those daemons are not optimized for resource, so which means they consume CPU and memory. And I believe there are a lot of rooms to do the improvement to reduce the resource consumption. But anyway, so in current current state of art deployments, cutting the resource consumption is never the goal of the Kubernetes objects, as far as I know. So they have some kind of resource requirements in the edge side, which I think was problem or was some people's concern, because they said, oh, my nodes are running all these apps only have, let's say, 2 cores, 4 gig. I cannot afford a solution that takes too much overhead. So that's one thing I think that's can place a challenge into leveraging Kubernetes to manage the edge use case. Another thing is the device management, which is another, which I think is a strong aspect of KubeEdge anyway. But to me, I think this is also challenging because there is no standard model and abstraction for this. I would say it's highly opinionated in terms of the API design and the real implementation about the controller. Supporting this, we are trying to, in the coming up slides, so we will talk about what is our way to resolve this device management, but I do think this is still challenging because there are too many types of devices with too many differences of requirements of running this. I would say that managing those devices in Kubernetes is quite challenging. Yeah, so this is the challenge that we see in terms of managing the edge use cases using Kubernetes. Next I will talk about some design that the OpenYurt was trying to use. Our design principle is kind of follow this way. It's like we are trying to extend in the Kubernetes without intrusive modification, which means we are trying to keep all the Kubernetes components as untouched, as native as possible. So, which also means we are trying to maintain full compatibility with upstream Kubernetes. This is kind of the key differences between our solution versus KubeEdge. Well, KubeEdge, at least in the previous or the version I was looking at, so it kind of changed the Kubernetes quite a lot. We don't do that. So we do everything is like additive. So it's not we don't do intrusive code modification to existing components. So OpenYurt is trying to support the edge characteristics like autonomy. We're trying to resolve the cloud edge communication problem. We're trying to provide the pool wire management. And so OpenYurt also trying to support a heterogeneous computer, like different computer architect, ARMS x86 and ARMS architect. But this is the thing that the main thing that we're trying to resolve. We're trying to make OpenYurt as Kubernetes native. So we generally just implement add-ons. We keep OpenYurt with upstream release. So I think every quarter we will have a kind of version upgrade to the Kubernetes base Kubernetes versions. We are trying to achieve 100% API compatibility using OpenYurt. Yeah, this is our design principle for this. This is the high-level architect about the OpenYurt. So in the cloud side, there are nothing but just a bunch of controllers. It has its own node controller to replacing the upstream node controller, just because we are trying to resolve that part eviction problem during if the node losing habits. We have to slightly change that behavior. This is unfortunate. We we have introduced a new United deployments to resolve the pool management problem in somehow, some kind of, in one aspect that, like I was mentioned about the application management. The cloud side also has a tunnel server, which is trying to resolve the cloud and the edge node communication problem, because they probably are placing different, to resolve that unidirectional access. So edge nodes can access cloud, but cloud cannot access edge node. So to resolve that problem, we introduce a tunnel service so that the cloud API server can call the Kubernetes API through this tunnel. In the node side, we have a few new components introduced. The major one is the YART hub, which you can treat it as a proxy to proxy all kinds of requests from the node component to the API server. So in a nutshell, if the node is offline, the node is disconnected to the API server, and the YART hub will kind of handle all the API server requests from node components, so that the node components still work if the node restarts. Yeah. Yeah. So this is pretty much the high-level architecture about the OpenYurt. In terms
I see in your diagram that Flannel is specifically called out as the CNI. Is that a requirement, or can you use other CNIs?
No, this is just an example of the CNI. So anything, so pretty much that any nodes, I think CNI needs to talk with API server anyway. So anything that's trying to talk with API server, we can support them to talk to the YART hub instead of API server. So Flannel is not, so we can support other plugins, not all, no, other than this Flannel for sure.
Okay.
Yeah. Okay, so let me briefly talk about how do we resolve the edge autonomy. So edge autonomy, so the goal of this, of resolving this problem is that the application availability is still preserved when the cluster edge networking is off. So the high level idea is that I think is Kubernetes Edge using a similar idea is like, we will cache the cloud data locally. So, and this is one. So we cache the cloud data locally. Second thing is we are trying to retain the IPO MAC address when part is recreated. But this requires some CNI support. So that's the reason I was mentioned Flannel. I believe we have some enhancement in the Flannel side to actually support this. But in I don't think we open source all this in the upstream one, because I don't know how many people will afford doing changes on the Flannel to support this. But I do see people just keep asking, can we keep the same IP if the node restarts? But this is, we are trying to resolve this type of problem. But another problem is caching, which is definitely we open source it in the sense that if the, we will cache all the cloud information whenever it is updated, not exactly whenever it's updated, whenever you, so let me try to explain the workflow of this. So if you look at the diagram, so any node components, so trying to, we kind of intercept all the network requests to the port number 10261, which is the API. So every time, so the node component trying to access API server, the YART hub will see if this API server is online or not. If this API server is online, which means so then the request will be directly sent to the API server through a load balancer. And the request results will be cached locally in the caching manager. So if anytime the YART hub find that the API server currently is offline, so it will serve the same API request by looking at the cache manager and to satisfy the request. Basically, if you trying to list the parts, but the node is offline, so the YART hub will reply with the parts list that it cached from the latest one. So that's typically the way how it does. Yeah, I think this is a common way that people are trying to resolve the problem that if the node is offline, and how do we satisfy the API server request for the node daemons running in the node? Yeah, this is the edge autonomy solution. The second one is the cloud edge communication.
Going back to the edge autonomy, does this also support an edge location power cycling?
Yes, exactly. So because we persisted in a local disk. So if you look at this diagram, so all the results are persistent in local disk every time. So if you node is restarted, the kubelet will get a list of parts from the local disk. So it will restart.
Okay, and then if they get restarted and recovered,
yes, exactly.
Even if you can't reach the control plane at the time.
Yes, exactly.
Okay, so thank you.
Yeah, sure. That's a typical way that people does. I think Kubernetes support the same. So they use the kind of database, SQL Server database for this purpose. So we are not doing that, fancy. We're still using a smaller, that text-based, file organizations for the data stored in the disk. So the second one is the cloud to edge communication. So the goal of this is that we're trying to still, for any reason, even if the edge nodes are placed in the internet, we still need to provide a way so that API server in the cloud can access Kubernetes, calling the log and ESCC APIs in the edge. In general, just people trying to just introduce tunnel services. Tunnel is pretty common to resolve this problem. And the only difference is that we are not implementing in-house tunnel services. We do have in the previous versions, but we decided to use the Kubernetes API Server Network Proxy and AMP project. So we use this project, and we use gRPC to support this tunnel. We also add routing policies in AMP. So we work in the upstream. So we talk with upstream guys saying that we are trying to use AMP, our edge solution, but we have one requirement such that we need to have a routing policy. So to see which exactly these requests are routing to, because the native AMP can route the resource to any AMP agent in node, but we do require to go to exactly just one of them. So we adding this routing policy is the AMP, and I think this feature was merged and it was supported in upcoming AMP release. And another thing is AMP, I think was supported after Kubernetes 1.18. We also trying to support this for previous versions. That's the reason we have an interceptor in the diagram, which does nothing but trying to convert the old version request to the new, I think it's gRPC or just HTTP2 kind of form. I forget the details. Trying to kind of convert the request from the Kubernetes request from the old version of API to the format that AMP supports. So that's pretty much what we did for the supporting the tunnel service. Even if the nodes, edge nodes are placing in the internet, so API server still can access it. The next one is pool aware application management. It's essentially does by two CRD. One is notebook controller, another one is a United Deployment controller. So notebook controller is pretty simple one. It's just trying to define a set of nodes which forming a pool. So the controller will do something like that. You can management all the label annotations or some of the nodes that belongs to node pool using this controller. So that you can easily just add in the labels, annotations kind of thing to all these pools in one pool. And the United deployments kind of work with the node pool so that we will kind of deploy a similar kind of deployments in different node pool with slight differences. So the API in the United deployments allows you to describe the differences about the.
So what would be the use case for these pools? Would it typically be one location is one pool, or is it a class of workloads that could be at multiple locations that are within one of these pools?
Yeah, so for now we don't have set directly, it's all up to users for now. So we just give some best practice saying that you'd better put the nodes in the same location in node pool, because we when we talk about the networking, so we are trying to make the networking in the local pool is connectable. So we are trying. So that's the reason if you define node pool, you'd better define the right topology that you want. So node pool is kind of the topology that you are trying to achieve.
Okay, so in that example you gave before of managing, say, 10 hospitals, you might make each hospital its own pool. Is that, yes, exactly. Would that be the typical expectation? Yes, exactly. Okay, thanks.
Exactly. So if you look at these diagrams, you can say pool A is one hospital, pool B is another hospital. So in different hospital, we give different deployment even for the same workload. And so usually, so even you have same services, but if the ending point are spread into different pools, and usually the network traffics we are sent to the endpoint that belongs to the same pool. So we are trying to avoid cross pool network traffics. This is kind of done. If you remember, so Kubernetes 1.18 supported the topology-wise service. It's kind of to work pretty well with that API change. So basically the Kubernetes service now you can specify the topology where the ending point should be trying to avoid to do the cross topology traffic. Yeah, so the pooling is also help to configure that region for the network traffics. So basically the east-west traffic boundary we can form through the pool. Yeah, okay. So yeah, the last one is the device management. So we are trying to, we're also trying to support the device management in OpenYurt, but we probably do it in a different way. The goal is we're trying to manage different edge devices with various communication protocols. And we're trying to provide a way that user can manage those devices like managing normal Kubernetes objects through the CREs. So we don't do we kind of leverage existing the edge device management system or even platform. So we only try to so in OpenYurt we only define a kind of set of APIs and the CREs. Then those CREs can work with we hope can work with many kind of very specific edge device management platform. You can see this as an interface layer or glue layers to connecting different edge device platforms. The 3D CRDs are device profile, which kind of represent different types of devices, and they just describe this device profile is usually provided by the vendor, describing what this device is and what are the API or the URL or the resources this device can be accessed through the vendor's drivers. And the devices and the device services is a CRD that can define the way that device connect to the cluster. Basically, it points to the device services that the vendor provided by vendor and running the node, so that the controller in the cloud side can access those devices. And the last one is actually device CR, so which can define the specific features of fields and people are trying to control or manipulate the device states, and also which is a CR that can represent the status of the current device.
So I just want to make sure I got this straight. Is OpenYurt opinionated on defining a way to manage devices, or is it open for plugins where you might be able to take another project, like I see in your diagram, you're using the stuff from EdgeX, but suppose I wanted to use Eclipse, Hawkbit, or the Acri project. Are those something you could use with this, or
That's
is
our
the
hope.
expectation that you'd use what's in this diagram?
Yeah, that's what we hope. So, but Acri we may not support that because that is slightly different than traditional edge device system. But for EdgeX styles, basically you have a platform and you have a definition. If the platform was designed dedicated to managing devices, and we hope this model can work because usually in modern, edge devices, you will have a profile anyway to describe the devices that you support, and you need to have a kind of service to describe where you can access those devices. This is all the high-level requirements, and it's up to the people to write the right controllers to support this API. This is our hope. We do in this project, we do write controller to support EdgeX Foundry to do these normal operations. But we haven't tried others, but at least for the EdgeX Foundry and some of our internal IoT solutions, we think at least this interface should be portable.
Okay, thanks.
Yeah. Okay, let me see. Yeah, for the use case, currently the OpenYurt is currently in production. Is the core components of the ACK is Ali Cloud Kubernetes at Edge product in Ali Cloud. In current use case, I'm just talking about the current use case. It serves as I call it a passcode. Basically, it is a foundation for various edge solutions like IoT parts, like CDN parts, like AI parts. So all these parts platform using OpenYurt to deploy the applications in various locations defined by the pools. That's the current major use cases of OpenYurt in the cloud side. We do have collaborations with VML for the edge management to support EdgeX Foundry. And we see some other use cases, but this is pretty much the current ones. Yeah, I don't, so the community-wise, so we're trying to enforcing a quality release since it starts. The entire project starts from June last year. We usually set up the 6-month roadmap. We have bi-weekly meetings, and we have collaborators from Intel, VMware, Leona Group, EDC. So yeah. All right, so that's pretty much what the slides that I have today. So I'm happy to answer any questions from you guys.
Thanks for this presentation. Well, I don't have any particular questions beyond this, and Steve jumped in a couple of times, clarifying things as we went. So it's all good from my side.
Yeah, so talking about, for Steven's question, talking about the comparison between this and the Kubernetes Edge, I think the biggest difference is we don't make any change to existing architecture. So we don't change Kubernetes for anything. So we just use any mode. So we're trying to stick to it. It may not be optimal for the resource, but I think from the maintenance perspective and the compatibility perspective, this is good, at least to relieve that side of the pressure.
So I suppose the implications of that are that if you are, say, an eager adopter that has been waiting for the very latest Kubernetes release and it gets published, you should be able to apply OpenYurt to it and get it running within a matter of days rather than waiting for some project to rebuild and
exactly
rebuild components you'd need to replace.
Exactly. So for me, for now, I think everything still it's kind of simple. It's kind of this kind of the whole idea is simple. The implementation is kind of simple. It can be. So we even have a conversion. So you can have a one-click conversion, convert a normal Kubernetes cluster to edge clusters. We hope everything just to be as simple as possible, at least for now.
And are you aware, like, I guess this also implies that a user could be on any compliant distribution, from a vendor or pure upstream open source Kubernetes, exactly. But they should be able to get it to work. How many different variations of distributions have you heard of people successfully using this on top of?
Yeah, but any data that we get are in production. So if you look at this, it is based on the Alibaba Cloud, so they will have same distribution. Mm-hmm. For other distribution, my only concern is we have some components that has a version dependency, like the AMP that requires you have. So although we have interceptor, but so I would say this way: we didn't test for all the distributions. In theory, it should work, but at least we are trying to make sure it should work for the latest release. And we also, so another problem is another problem of leveraging the upstream Kubernetes is that upstream Kubernetes itself is changing drastically. For example, if you are aware of that part, topology service support, the topology service support, which was added at 118, but it's got deprecated to 121. So then which bring trouble to us. So if we build a solution, based on that, we will have compatibility issues when we reach 121, right? So sometimes we decide to use the other way around. So instead of using that API, let's just add some logic in the YARD hub. So we kind of filter the endpoint that you can see, because YARD hub is just the proxy, right? You can filter all the requests that you are presenting to the kubelet. So we can use YARD hub to filter all the requests, all the endpoint that are outside of the current node pool, which served as exactly the same as the having the API support for the service topology. So this kind of trick that we sometimes facing this dilemma. We trying to use upstream API as much as possible, but if it is changing drastically, we probably will holding back to use our own solution, at least until it reaches a stable stage.
Another question I have is, you alluded to the CNI being involved with recovering an IP on an edge node. What would I need to look for in the CNI to determine if a particular CNI supported that functionality or not, or do you have a list published in the docs? Or
yeah, so that's a thing. So in our internal, it's not. So this is kind of this complicated procedure. It's not a single component change. You need to use a local IPAM. So that's provided by the Linux, so it's all about IP management. Some CNI does it, some CNI may not does it, may not support it. So you're saying the CNI has to be prepared to deal with a local IPAM to get this to work? Exactly. So instead of open source the entire solution, so we will kind of release a document saying that if you really want to support this, what would be the steps to do? But that steps may not apply in your environments because it's highly environment dependent.
What would go wrong if you couldn't recover the original IP? What breaks?
It's just the IP changed. So I think it's all about application. So in theory, the cloud native application shouldn't care about IP in theory. But in fact, many applications that are migrated from the on-prem data center to the cloud, they rely on the IP for whatever reason, because maybe they have their own platform to do the management. They need to know the IP. So that's the whole thing. In general, if you just write I think most of modern applications try to avoid directly info the IP.
So what of the current user base, what is the distribution of the size of these clusters at edge? Are they typical multi-node?
yeah,
Kubernetes Edge, or
Yeah.
does this thing make sense? If I had very low resource edge nodes, like one host rather than multiple, and maybe it was very small in resource, something like an Intel NUC size thing, or maybe even a Raspberry Pi 4. Does this make sense, or is it kind of overkill for those kind of use cases?
At least when we do the demo, we use the RESTful. We use that small RESTful to do the demo, so it's supported. Yeah. But in reality, at least for the Ali Cloud the Edge users, they don't have strict limitation on the edge side node resource. They typically have a server. In general, they have a server. At least they have one server. So in some other scenario, which big scale, we do have a cluster supporting hundreds of nodes that is supposed to that's spread to different regions. Different pool. We have that large scales. Like for CDN context, that's very normal. So because for CDN, you are trying to distribute the CDN distributed networks. You involves a lot of nodes spread to everywhere, right? In the whole country, probably. They trying to use a centralized control plane to do the management. So they choose this OpenYurt to do as a foundation to support that pass layer. Yeah, so that's a reason that we are not putting very strong efforts trying to reduce the footprint of the node components.
Okay.
Yeah.
Yeah, some of that might be outside your control anyway, since you have to land on top of a Kubernetes distribution. But
yeah, so if your edge node has very limited resource and the number of pods that they can run still limited, and if people start to worry about the workloads and think that the right way for them to do is expand the resource instead of squeeze the control plane, right?
Is ARM considered a supported platform, or is that not something that people are typically doing with this? ARM processors as opposed to x86.
ARM, are you saying that do we support ARM?
Yes.
Yeah, we do. We do. Yeah, we do support ARMs.
Okay, and then I guess another thing people might be interested in, what kind of open source community are you running with this? Do you have your own meetings going on? And what if someone was to adopt this or do a proof of concept, where would they go to get support? Do you have a Slack channel or some kind of a mailing list, or how would they go about it?
So yeah, okay. Usually we just go through the GitHub issues. We kind of quite responsive to GitHub issues. And we have a Slack channel, which is we post in the GitHub. The bi-weekly meeting, unfortunately, currently is Asian time stamp, and all the attendees are coming from China. We don't, so we are still facing the same challenge that you guys face. So we don't know how to manage in the US ones.
Right.
So I think this we are going to the table for once we have, I say a few US users. Once that happens, I think we should think about start with the US timeline meetings. But mostly for now, the major users of the OpenYurt are coming from China at this moment. So that's the reason we're hosting the meeting for Asian timestamp. But any people can just post requests and questions in the GitHub issues. We are very responsive to that.
Okay, I think I've got a good compare of this versus KubeEdge too. But could you maybe also say a few words about how this might contrast to the SuperEdge project?
Oh, SuperEdge! I think SuperEdge is they are coming. They share OpenYurt and SuperEdge. They share a lot of commonality. So you can treat them as pretty similar, but we probably will diverge in some places, like the edge management is a new Another thing is we probably will address some I would say Kubernetes also address something about the autonomy in the sense that they have a feature saying that if one node is crash, if one node is crash in the edge side, they provide a way to tell the APS server this node is crash. Please evict the pods. They have some feature like this. This is also the ask from people. So saying that you guys trying to avoid the pod evictions, but what if the node is actually crashing? I do want pod evictions. How to handle that? We probably will do that through a different way in OpenYurt, but they are very similar.
And is there any technology built in this to manage your remote edge locations just centrally with no experienced IT staff to fall back on out at the edge locations? Like, can you pull off initial deployments by, I don't know, pre-composing this on boxes that are shipped to a location and just powered up? Or is this something that requires at least a little bit of hands-on during the maintenance cycles?
Exactly. I think that's a very good question. So when we discuss this node pool design, I actually have the same question to the guys. But unfortunately, currently, people still do the node management through labels kind of thing. You require at least one manual step to give the labels. There's no automation to do the things that you said. Okay, automatically detect all the regions, trying to avoid this kind of manual work of labeling those nodes. This is not happening right now, but I hope we can do better.
I guess the other thing that frequently comes up in these groups are security concerns when these things go out to edge locations that maybe have less than good physical security on these nodes, and what your risk profile is if somebody manages to go at one of these edge locations and say physically steals a node or something. In terms of what goes on there, what are your risks?
I think it's a general problem. So for Kubernetes, so for security, we largely leveraging the security aspect of Kubernetes. So the problem is that you mentioned steal nodes, apply to the Kubernetes. But some other aspect is that currently this model doesn't support. I would say, although Kubernetes has multi-tenancy support, I don't think OpenYurt is ready for multi-tenancy because we cannot enforce the strict requirement to the edge side saying that you have to run your container in the sandbox runtime. We cannot make that assumption. That's the reason I don't think OpenYurt is good to support the multi-tenancy use cases. Other than that, if you have a single tenant, so you as a single tenant own the entire infrastructure and the cluster, so you should find a way to deal with the physical attack, not in the software attack. Yeah.
And the tunnel you're opening, is it versatile enough to accommodate kind of a concept of a primary network and a fallback? There are some of these edge scenarios where they'll attempt to use just a public internet connection as your mainstream way of getting back to the central, but also have a fallback that goes over, I don't know, a cell service or something, or even a satellite uplink, but it isn't the preferred one because maybe it's more costly. Is it agnostic as to what the topology is of these connections to your edge nodes?
So this tunnel, the concept is pretty simple. Like you just establish HTTP connections because the connection initialized from the edge side, right? You just create connection to the server side. So
as long as the edge side can get an IP connection back, it should work.
Yes.
Okay.
It's pretty common. So we don't do any. So we do see the cases that there is complete network isolation.
which means even the nodes in the edge cannot access the IP of the public IP. We see some cases that to support that this tunnel doesn't work, but instead we will support like private network kind of thing. You need to have a vendor routing, vendor switch support. It's hardware switch support.
Well, a big concern with that, with regard to Kubernetes, orchestrating containerized workloads might even be pulling container images. Is the expectation that they pull them from the central cloud location, or is there a potential for them to host an image registry locally or regionally so that they don't have to go?
We do see cases that people hold the image locally. They don't want to use cloud service for imaging. They have their own security concern for that.
Okay, and that functionality is nothing special to OpenYurt then. That's just something you could do with Kubernetes itself, right?
Yeah, so yeah.
Okay, I think I'm out of questions, but thanks. It was really interesting. Does anybody else have anything?
No, thanks for driving the discussion.
Yeah, thanks. And if you could send a link to the deck, I'll post it to the group, either the deck itself or print it out as a PDF or something in case people want to go back. And then maybe also a list of where people can go. I know you can go get it from the GitHub, but links to your Slack and any meetings you might have might be of interest.
Sure. I think I will give you a PDF version of the stack through the email. I'll have you.
Okay.
Email.
Okay, well, thanks again. That was really informative, and I enjoyed it. You're welcome to come back to the group anytime too for updates as new releases come out, or if you even want to get feedback from potential users. And we routinely talk about subjects, things like your device management. So there might be an opportunity if you want to come back and just throw out questions about, hey, how are people doing this and what's already out there? Because a lot of these niches have kind of standalone open source projects that are really interesting in getting momentum. Some of them in device management even come from different sectors than traditional IT. I think that Hawkbit was done to manage things in vehicles and, to manage devices, getting firmware updates even in automobiles and things like that, and scales to managing millions of devices. Some of these things I think got incubated independently. And I found that a lot of these projects, they don't even know each other exists, but I think there's opportunities to combine these kinds of things together.
Exactly. Okay. Yeah, I think that's a good idea. So yeah, let me see. So how because this is still an ongoing project. So let's see how it goes. If it goes well with EdgeX Foundry, I think we can share some of our experience and show even some demo if you guys are interested in this meeting.
Okay, well, thanks again. And with that said, I'm going to close the meeting. So thanks everybody for attending.
Thank you.
Bye-bye.
Take care.